Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. The series of lectures cover about mobile and pervasive computing. The lecture series covers about cellular wireless networks, global system for mobile communication, that is GSM, its architecture, GSM protocols, connection establishment, frequency allocation, handover in GSM networks, security issues, and the last one is General Packet Radio Service, that is referred as GPRS. The content of today's lecture is about General Packet Radio Service. It provides the flexible data transmission. It adds the data transmission facility to the global system for mobile communication that we will learn now. The General Packet Radio Service, that is GPRS, provides packet mode transfer. It supports flexible and powerful data transmission. The GPRS supports the packet mode transfer. In the GSM, the voice calls are transferred between the mobile stations and between the GSM network. Here the main aim of the GPRS is to provide a data service that is in the form of packets. So, it adds some flexibility for data transmission, and the infrequent transmission of small volumes, for example typical web requesters, and frequent transmissions of small or medium volumes, for example the typical web responses, are supported by the GPRS. So, in the data transmission, generally the users will make a small kind of requesters to the network. For the request, the network will provide a large volume of data towards the user. So, always the frequent and infrequent of data transmission is the nature of a data transmission. Now, GPS is intended for support the frequent and infrequent transmission of data. GPRS uses the existing network resources more efficiently for packet mode applications. Existing network architecture. So, in the previous lectures we have learned about the global system for mobile communication, that is GSM. Now, GPRS needs some extra components so that along with the voice communication the data transmission is possible, and in the GPRS the users can specify the quality of service, that is QoS. So, they can specify the delay, they can specify the clarity of the data, they can specify the end to end delay. So, these are all the various QoS parameters. In the GPRS network the users can specify the QoS. GPRS also supports broadcast, multicast and unicast service. We know that three type of services we have. So, broadcast, that is transmitting the information to all the users in the network. Multicast is nothing but transmission of data to a subset of users, and unicast is one-to-one communication. GPRS provides the efficient and cheaper packet transfer service for typical internet applications. So, that is purely based on the packet transfer. So, the main aim of the GPRS is to provide the data over the internet to the mobile users. So, now the users can access the data from the internet through their GSM network, and in the GPRS the users will be charged not based on the time they are using, but instead they are being charged based on the amount of data they have consumed. So, based on the data transferred amount, the users will be charged. So, the GPRS is based on the success of the packet oriented internetwork. In general, we have two type of networks, circuit oriented networks as well as packet oriented. In the circuit switched method, the circuit is established prior to the transmission of data. In packet oriented all, we have two type, one is virtual packet oriented network and another one is datagram approach. In the virtual circuit switched network, the path is virtually established between the senders and receivers. So, GPRS needs additional network elements, that is some additional softwares and hardwares are required, that we will learn. For the new GPRS radio channels, the GSM system can allocate between 1 and 8 time slots within TDMA framework. So, in the previous lectures we have learned that the GSM network is using the frequency division multiple access along with the time division multiple access. So, the frequency bands are sliced on the timeline. Now, some of the slots can be used for the GPRS users. So, now the GSM network allocates some channels for the GPRS users. So, time slots are not allocated in a fixed. So, in the GPRS network, time slots are not allocated in the fixed manner. So, based on the demand and the current load of the network, the time slots will be allocated to the GPRS users. The GPRS allocates at least one time slot per cell to provide the connectivity. So, this is the minimum level of assurance given by the GPRS network. So, the GPRS offers two kind of packet transfer service. One is point to point packet transfer service, that is PTP. The second one is point to multi point, that is known as PTM. Point to point packet transfer service. In the point to point packet service, we have two versions. One is based on the connection oriented approach and the next one is connection less. So, in connection oriented approach, the path will be virtually established between the sender and receiver before the commencement of the data transmission. But in case of connection less, there is no virtual path will be established. So, the data will be directly transmitted between the sender and receiver without establishing the virtual path. So, we have two kind of applications. So, some of the applications they need the connection oriented approach. So, they want to send the acknowledgement back to the sender, they want to manage the data loss and all. So, for very sensitive applications, we will go for the connection oriented approach, but in some of the multimedia applications they do not want to send any acknowledgement signal back to the sender. So, these kind of applications can use the connection less approach, and also the connection oriented approach they are using some handshaking signals to establish the path. So, it is a time consuming process, but in case of connection less services there is no path is established. So, no handshaking signals are transferred between the sender and receiver. So, they are the less time consuming services. So, the PTP connection oriented network they includes the ability of GPRS to maintain the virtual circuit. This type of service corresponds to X.25. X.25 is a standard which uses the connection oriented service of GPRS. PTP connection less, as I already mentioned, some of the applications they can use the connection less service. The next type is point to multi point. So, here the users can specify the quality of service, how much delay they can tolerate and how much packet loss they are able to manage. So, these are all the quality of services that can be mentioned as the user profile or requirements profile, and based on the profile the connection will be established. So, this is referred as point to multi point or sometimes point to multicast service. The users can specify the QAS, that is quality of service profile, and this determines the reliability class and delay class of the transmission and the user throughput. throughput is nothing but the amount of data transferred without loss. The GPRS should allocate the required amount of radio resources to provide a better service to the GPRS users. And based on the reliability of GPRS, they have defined the 3 type of classes: reliability class 1, 2, 3. Reliability class 1, some of the applications are very error sensitive, even they will not be able to manage with a single packet error. So, these kind of errors are also not able to correct the errors by themselves. So, such kind of very error sensitive applications can choose the reliability class 1. And reliability class 2, some of the applications they have greater error tolerance. If some of the frames are corrupted, still they will be able to manage with the error data. So, these type of applications can choose the second reliability class. And the reliability class 3. So, this is used for error insensitive applications. So, some of the applications they are insensitive to the error, and also they have the ability to correct the errors occurred. So, these kind of applications can choose the reliability class 3. And delay. So, delay is the important parameter in all the telecommunication systems. So, delay is the time taken for a data to be transmitted between the sender and receiver. So, all the telecommunication systems are trying to reduce the delay to achieve the better service quality. Now, the delay in the GPRS network is caused by various factors. They are the channel access delay, that is the time taken for the GPRS network to provide the channel between the user and the network. Next one is the coding for error correction and the transfer delay. So, the transfer delay is nothing but the actual delay that is taken for the data transmission between the mobile stations and the GPRS network. However, the GPRS does not produce additional delay by buffering the packets as store and forward networks. So, we have some network that is referred as store and forward. They used to store the data if they are not able to deliver the data as soon as they received. And in some networks, if the destinations are not in the switched on condition, they will store the data, and after some times the destinations will be turned on. So, they will forward. So, this is referred as store and forward kind of mechanism, but GPRS does not follow that standard. So, the GPRS will always try to send the data as soon as possible or as fast as possible. Then GPRS security. All the telecommunication systems are trying to provide the security for their users. In the previous lectures, we have learned that the GSM is also providing the security to its users. So, they support anonymity, they support authentication, authorization. So, they are hiding the real identity of the users over the air interface. So, obviously, the GPRS is also providing some security to its users. GPRS includes several security services. They are the authentication. The users should be authenticated, that is the user should be validated before accessing the services, and access control, user identity confidentiality and user information confidentiality. So, here the user identification should be protected, the real identity should not be exposed to anyone, as well as the users are transferring and receiving the informations in the form of packets. So, that packets should be secured, and also the GPRS completely supports the anonymous service. There is no separate GPRS architecture we have, but we are adding some components to the existing GSM network. So, that is why we used to learn that the GSM network can be extended or can be modified to support the GPRS network by adding some of the components. The GPRS architecture introduced some new network elements to the GSM. They are GPRS support nodes, they are referred as GSN, gateway GPRS support node, that is GGSN, serving GPRS support node, that is SGSN, and GPRS register GR. Let us have a short break. We shall continue our discussion after the break. Welcome back. Before the break, we were discussing about the basic objective of GPRS network and the security support by the GPRS network to the users. Now, let us start discussing about the GPRS architecture. So, the GPRS architecture adds some extra components to the existing GSM network. They are GPRS support nodes, gateway GPRS support node, serving GPRS support node and GPRS register. Let us learn one by one. So, GPRS support nodes, that is GSM. Now, all the GSMs are integrated into the standard GSM architecture. So, many new interfaces have been defined through the new interfaces. Now, the GPRS supported nodes are connected to the GSM architecture. The second important component is gateway GPRS support node, that is GGSN. We know that the GSM network is connected with the public data network, that is the network which is out of the GSM network. GPRS support nodes GSM. Now, all the GSMs are integrated into the standard GSM architecture. The GPRS network defines many interfaces. Through the interfaces, the GPRS support nodes are connected to the existing GSM architecture. And the second component is gateway GPRS support node. This second component is used to connect the GSM network to the outside world, that is the public data network. So, we have many public data networks. Now, all the outside network can be connected with the GSM architecture using this node. The GGSN node has the routing information for all the GPRS users, and it actually performs the address conversion. It tunnels the data to the user via encapsulation. Now, the data encapsulation is achieved in this node. So, the data is encapsulated and tunneled to the network. The GGSN is connected to the external networks. So, internet protocol based network or X.25 or the outside networks, they are connected through the GI interface. And also the GGSN transfers the packets to the SGSN via IP based GPRS backbone network through the GN interface. GN interface is used to transfer the information between this node to the SGSN. The next important component of the GPRS architecture is serving GPRS support node, that is SGSN. This component actually requests the user addresses from GPRS register, and it keeps track of the individual mobile station's location. Also, the component is responsible for collecting billing information. So, based on the number of bytes used, the users will be charged, and several security functions such as access control are achieved using the SGSN. And also SGSN is connected to the base station controller. Now, this is on the same hierarchy level as an MSC. In the GSM architecture, the mobile stations are connected with the base station controller. Now, base station controllers are connected to the mobile switching center. Now, the corresponding node or the SGSN and MSC are in the same hierarchical level to a mobile station. So, a BSC is connected to the MSC in one side, at the same time a BSC is connected to the SGSN. So, now SGSN and MSC are in the same hierarchical level. And the next component of the GPRS architecture is GPRS register. So, this register stores the user addresses. Actually, this register is a part of the home location register, and it stores all the GPRS relevant data. So, the packet data is transmitted from the public data network and GGSN, SGSN directly to the BSS and finally to the mobile station. Now, the data is transmitted towards the PDN. Now, PDN transmits the information to the mobile stations through SGSN. Now, the mobile switching center or MSC is responsible for data transport in traditional circuit switched GSM, and it is only used for signaling in the GPRS scenario. We know that in the GSM network, the mobile switching center has a major responsibility. It has to signal and it has to allocate the channels between the mobile stations and the network. But in case of GPRS, the mobile switching center is only providing some signalings, and they are not directly involved. So, before transmitting or receiving any information with respect to a mobile station, it has to be attached to the network first. The attachment procedure includes assigning a temporal identifier. Now, the temporal identifier is called as the temporary logical link identity, or TLLI. This identity is used to attach a mobile station to the GPRS network. And chippering key sequence number, that is CKSN, for data encryption. So, the GPRS has to provide the security for the user data. Now, the CKSN is used to provide the data security using the data encryption. For each mobile station, a GPRS context is set up and stored in the mobile station and in the corresponding SGSN. So, normally before accessing the GPRS services, we have to make a request to the service providers. So, they will create a set of context and they will give that information. So, generally that is referred as configuration. Now, that configuration has to be stored both in the mobile station as well as in the SGSN. So, after that we can access the GPRS service. Now, that GPRS context comprising of the status of the mobile station, that is, the mobile station can be ready or idle, or it can be in the standby mode, and the CKSN, that is the chippering key sequence number used for data encryption, a flag indicating if compression is used. So, sometimes either the network or user can use the data compression mechanisms to efficiently use or to effectively use the network bandwidth. So, if the compression scheme is used, they can specify through the flag. And routing data, that is TLLI, the routing area RA, the cell identifier, that is the current cell, and the packet data channel identifier. These are all the informations stored in the GPRS context data that has to be stored in mobile station as well as in the SGSN. So, now this is the overall architecture of the GPRS. Now, we know that the mobile switching center, home location register, equipment identity register, visitor location register, the mobile station, BSS, these are all the parts of the core GSM architecture. Now, GPRS introducing some new components to the existing GSM network. So, they are SGSN as well as the GPRS register. So, many kind of new interfaces like GI, GN and GB. Now, the GB is an interface that specifies the data transmission methodology between the BSS as well as the SGSN. Now, through the GI interface, the GGSN or the gateway GSN is connected to the public data network to access the internet. So, as usual, this is the radio interface or interface that is going to connect the mobile station with the BSS. Now, the specifies the channel accessing mechanism. It specifies the TDMA and the FDMA methodology along with the SDMA. So, GPRS register is a part of home location register. It stores some information about the GPRS users. So, here the mobile switching center is only supports by signaling in the data transmission of GPRS. It does not directly involve as it is dealing with the GSM voice call transfer. Before attaching and detaching a mobile station to and from the network, some of the mandatory operations has to be performed. They are: the users has to be validated, and location management. The location of the mobile station has to be identified, and chippering. So, using the data encryption key, the chippering method will be defined. So far we have discussed about the new components that is introduced by the GPRS network to the GSM network, and the GSM network is converted to support the data transmission in the packet delivery mode. Now, let us start discussing about the GPRS protocol architecture. In the GPRS protocol architecture, we have the radio layer, medium access control layer, radio link control, and frame relay control or frame relay protocol, BSSGP protocol, and logical link control protocol, and the various new interfaces like GB, GN. Now, The GA is the interface that is used to connect the entire GPRS architecture to the outside world. In the diagram, the outside world like some other PDN like X.25 or IP based network is not mentioned. So, here the internet protocol is used to identify the mobile stations in the entire network, and for providing the connection oriented as well as connection less service, the GPRS network is using the transmission control protocol as well as user datagram protocol, and also the GTP protocol is used. Let us learn all the protocols one by one. All the data within the GPRS backbone, that is between the GSNs, is transferred using the GPRS tunneling protocol. So, we have the GTP, GPRS tunneling protocol. So, within the network the data will be used and it is using the GTP protocol. GTP can use two different transfer protocol, either the reliable TCP and the UDP, that is unreliable data applications. As we already discussed, some of the applications need very high reliability, even they will not be able to tolerate with a single data loss. So, that kind of applications can go for using the TCP protocol. Some applications can tolerate the data loss, or they can compromise the quality and all. So, these kind of applications can use the next one, that is the UDP protocol. Now, GTP defines, based on the applications, the GTP defines the different kind of protocols. The network protocol for the GPRS backbone is IP. So, IP is nothing but internet protocol. In common computer networks and all, the IP protocol or the IP address is used to identify a system in the entire network. In the GPRS backbone network, IP is the network protocol. So, the IP protocol is used to identify the users in the entire network. To adapt to the different characteristics of the underlying networks, the sub-network dependent convergence protocol, that is SNDCP, is used between SGSN and MS. Different characteristics. So, various kind of heterogeneous components are used in the network. So, we have to make the convergence between all the sub networks. So, we are using these protocols to provide the convergence between various kind of devices or network devices within the GSM network. To achieve a high reliability of packet transfer, a special logical link control is used, which comprises automatic repeat request and forward error correction mechanism. Here we are using the links to connect the mobile stations to the network. So, that link should be error free. So, automatic repeat request and forward error correction mechanisms are used to provide the reliability. If some data is lost using the acknowledgement signal, the data can be retransmitted. In some scenarios, the data can be delivered with the error. So, the receiver can intimate the sender using the negative acknowledgement. So, forward error correction mechanism also used to provide the better data reliability. So, now the logical link control layer is using the ARQ as well as forward error correction mechanism to achieve the high data reliability in the GPRS network. A base station subsystem GPRS protocol, that is BS-SGP, is used to convey routing and QoS related information between the BSS and SGSN. So, we already mentioned that the part of the GSM network is BSS. Now, BSS is connected to the SGSN. Now, these two systems has to be integrated, or they should support some interoperability, so that some quality of services can be achieved. So, now the users will create the QoS profile, that is referred as the requirement profile. The requirement profile will be given to the network. So, based on the profile and based on the available resources, the users will be provided with a good QoS based services. The radio link protocols are needed to transfer the data over the interface. So, radio link protocols are used to transfer the data between the mobile station and the GPRS networks. The radio link protocol RLC provides a reliable link, while the medium access control, that is the MAC, controls the access with the signaling procedures for the radio channel and mapping of the LLC frames onto the GSM physical channels. So, now medium access control provides the method. So, it defines how to access the medium without collision. So, all the public data networks are forwarding their data packets for the GPRS users directly to the GGSN. Now, GGSN asks the current SGSN for the tunneling parameters and forwards the data packets to the MS. The PDN networks are sending the data to the GGSN, and the GGSN are contacting the current SGSN. Now, the current SGSN is responsible for transferring the data packets to the users. Let us summarize what we have learned in the today's lecture. Flexible and powerful data transmission is supported by the GPRS network. The GPRS radio interface at does not require the fundamental changes compared to the standard GSM. GPRS also supports broadcast, multicast and unicast services. GPRS does not produce delay by buffering the packets. Let us pose some questions for our understanding. Identify the additional components needed to the GSM network to support the GPRS. Differentiate point to point and point to multi-point service. What is the use of GPRS register? What is temporary logical link identity? With this, we conclude our today's lecture. In the forthcoming lectures, we will learn about the unit 2, that is about the wireless networks. Thank you.